As the name suggests, relational databases are best at storing and retrieving relational data. That's the kind of data that fits neatly into multiple tables, each consisting of rows and columns of relatively homogeneous data, all related through mechanisms such as foreign keys. Most of the material in the SQL Server 2012 courses cover relational data, since SQL Server is a relational database system. But the reality is that sometimes you have chunks of data that don't fit neatly into the relational model. One example of commonly used non-relational data is hierarchical data. This is data that defines some kind of hierarchy, such as an organizational chart or part subassemblies to build complex objects like an automobile. If the structure is rigidly set with a limited number of levels, you can do a decent job of representing the hierarchy with a table for each level, or using other techniques. But it can be very difficult to represent the hierarchy if the structure needs to be flexible. You can always store hierarchical data outside of SQL Server. But over the years, people have come up with various ways of adapting hierarchical data to fit the relational model. Some of these techniques include table self-joins. In a table self-join, you use a single table to contain the hierarchical data. The table has a foreign key to itself, thus the name self-join, in order to reference another row in the table. A good example of this is the Northwind Employees table, which has a Reports To foreign key field to identify the person to whom an employee reports. You can use that field to construct the Northwind Sales organizational chart. Another technique is using XML. XML data is inherently hierarchical, consisting of elements that entirely contain one or more child elements in a structured hierarchy. SQL Server 2005 introduced XML as a native data type, and Microsoft integrated it well with relational data. XML is handy because you have a great deal of flexibility in how you define the hierarchy. But you have to learn specialized methods to work with the data, and searching and sorting on the data can be problematic. Another option is to roll your own. SQL Server 2005 also introduced the capability to create your own custom data types using the .NET Common Language Runtime, or CLR. Many people took advantage of this feature to create their own hierarchical data type, with all the features to support their needs. SQL CLR types support properties and methods, so the type could implement behaviors as well as custom data structures to support hierarchical data. Such custom types were far from trivial to implement, and it took a lot of work to get right. And because developers and administrators frequently need to store and work with hierarchical data in SQL Server, Microsoft introduced the Hierarchy ID data type in SQL Server 2008. This is a compact object that you can use to manage hierarchical data using materialized paths. It's compact in that it uses very little storage, and it materializes paths and manages the hierarchy for you. It's a system CLR type, which means that Microsoft implements it via .NET code. Because it's a system type, you don't have to enable custom SQL CLR code in a database before using the Hierarchy ID data type, as you must for your own custom SQL CLR code. You can use the Hierarchy ID type to represent organization charts, map a file directory system on your hard drive, create an assembly part chart with subassemblies, represent project tasks, and for many other uses. The type has rich support with methods that provide many ways to maintain the hierarchy, such as making arbitrary insertions and deletions, as well as relocating sections of the hierarchy to other places. There's no magic to the Hierarchy ID. Although SQL Server gives you everything you need to maintain the integrity of the hierarchy, it doesn't automatically enforce hierarchical relationships. You have to do that in your code using the tools that are part of the data type. The Hierarchy ID type also does not guarantee uniqueness, but you can enforce uniqueness in other ways, such as with a unique constraint on a Hierarchy ID field in a table. Now I want to talk a little bit about some of the details of the Hierarchy ID data type. And the first is indexing. You can index a field of type Hierarchy ID in two ways: depth first and breadth first. Which of these methods you use will determine how SQL Server navigates the hierarchy when searching for or listing nodes in the hierarchy, how the data is stored, and the performance of queries that involve the hierarchy data. All right, so first I want to talk about depth-first indexing. With depth-first indexing, the children of a node are stored near the parent, closer than the parent's siblings. This indexing scheme is optimal when you often need to search subtrees rather than across a single level. And this is the default index type when you index on the hierarchy ID field. Okay, here's a hierarchy that I'll use in order to explain what all this means. The image shows a hierarchy of LearnNowOnline instructors and authors. Okay, no such hierarchy exists, but if it makes it easier to understand, consider that this is the planning organization for the fantasy instructor annual picnic, whatever. Okay, so Don, me, I'm at the top of the hierarchy, mainly because I missed the meeting where the committee chair was appointed. And Ken, Doug, Phil, and Martin report to me. At the lowest level, Jan and Wally report to Phil. If you were to implement this hierarchy using the hierarchy ID data type and index it depth first, SQL Server would navigate the hierarchy as I show here. It would start at me, Don Kiley, and then proceed to Ken, and then over to Doug, over to Phil, and would go down the hierarchy to hit Jan and Wally before continuing with Martin. Okay, so let's look at that one more time. So depth first means it's going to visit the children before it continues to visit remaining siblings. Okay, so down to Don, from Don to Ken, over to Doug, Phil, down to Jan to hit the children, and then back up to continue with the siblings at that level 1. So this shows why this type of index is more efficient for subtree searching, because it visits children before continuing on to the siblings. Depth first. With breadth first indexing, SQL Server visits all nodes in one level before moving on to the next lower level. Sibling nodes are stored near each other, making this type of index optimal for searching direct subordinates. In order to create a breadth-first index, you have to index on both the node level and the hierarchy ID node. Okay, here's that instructor hierarchy once again. And once again, I'll show how this indexing works. So this time, indexing starts at the root, me, going to Ken, and then to Doug, to Phil, and continuing across to Martin before going down to the next level and picking up Jan and Wally. So quite a different way that SQL Server is going to navigate a breadth-first index. And once again, go all the way across all of the nodes within a level, and then goes down to the next lower level. All right, so this is a relatively simple, very shallow hierarchy, but you could have far more levels and lots of subtrees going across here. And so it'll visit all nodes in level 0, then all nodes in level 1, and then all nodes in level 2, continuing on with 3, 4, 5, and so forth. SQL Server includes a full range of methods that you can use to query and update the hierarchy, and a few include getRoot, which returns the root node, the topmost node in the hierarchy. getDescendant and getAncestor return nodes relative to the specified node. getLevel returns an int that indicates the level in the hierarchy, and remember that the root is 0. isDescendantOf returns a Boolean value if the current node is a descendant of a specific node. And then getReparentedValue lets you change the location of nodes in the hierarchy. Kind of a funky name for that one. It's somewhat unintuitive, but a hierarchy can have more than one root node if you use compound keys with the hierarchy ID field. But most of the time, you'll have a single starting point into the hierarchy.